Hello everyone, welcome to Lecture 9. We will talk about functions. I'm your instructor, Ms. Laura Low. We are in week 4, so on the other hand, we kind of a quarter past this semester after this week. So in this week, we will talk about functions and the groups. In Lecture 9, the first part, we will do the chart review. And the second video, we will talk about how to define functions. So after this week's lecture, you will learn more technology how to compute your data set and analyze your data set or present your data set. Yeah, last week we talked about different charts. We show you how to create different charts use the Python code. So we have the line chart, we have scatter plot, we have the bar chart, and histogram. So why we use those charts? So charts can convey a lot of information in an interpretable manner. Generally speaking, humans are good at noticing patterns in visual media. So you can see here with specific, say, pattern. Remember, before we introduced the chart, the previous week we talked about how to create the table according to you have text file. So you can display the table information on Python as well, but we need to read each column one by one. Then we can see the number. So sometimes you see the number, maybe you just notice, oh, what kind of number in there? You not really can see the patterns yet. So that's why the first thing we get the data from sometime in the text file. Then you read as the table. So we have different columns. Of course, the first thing we will just see the data to see which column we are interested about. Maybe they have some relationship. But in order to really see the relationship between the columns, or we say between the attributes, we need a chart. The chart can really show us the pattern between those attributes or just in one attribute. So in the last 2 weeks, remember, we learned how to generate and correctly interpret visualization. So we talk about we using the line chart or scatter chart for the numerical data. So for the line chart, you need to make sure they usually both line chart and scatter chart, we will have 2 numerical attributes. Okay, so the line chart usually is your x-axis. They need to be in the order. So maybe the value change according to the years. But scatter chart usually is that 2 numerical attributes. They don't really have the gradually change in the time or distance in the order. So that we use a scatter chart to see the relation between that 2 attributes. We observe if they have any change between that scatter located. So then you have your bar chart can use for the categorical data. So we can see different category. How if the height, if the you can say height or the width is longer because they have the same interval. So then we can see they have more the distribution between different categories. Then you have the histogram. Yeah, histogram are using for the numerical attribute distribution as well. But sometimes it's not. They have the continued change for the data. Actually, we want to use that. We want to group those numerical data. So then we use the histogram. So then we need to create the bins to make them in different groups. So by the visualization, we can see using the area. The area will show the total percent in that interval. So that's why the first thing after you read the data set in the table, you need to know how to put that in a table to manipulate the column or something. When you notice any column you are interested about or the row you are interested about, we isolate that part of the table. So what you want to visualize according to what kind of data you want to present. So in this week, we will continue to talk about more tools we can manipulating the data you have. So then you can see what kind of data you really want to visualize. So we'll complete the tool set of the table operation. So the tables here, of course, represent the data set. So before our discussion question, to give you a question to see which chart you need to use. That's finished the last week. At the end, we have one discussion question talking about the histogram height. So we just quickly give you the answer. So how about we really see how we will write the answer in the code. So remember, for the histogram, area is important. The area of bar actually showed the total percent in that bin. So the bin area actually is the height times the bin width. Sometimes your bin widths, they are not the same. So that's why the height will change. So the most important thing you need to be careful what the area mean, what the height mean, what the bin width. So the bin width, of course, that means the interval for different for each group. But area here is your total percentage in that bin. Or here they say how many individual in that bin. But the individual also we can divide by total how many individual to translate into the percent. So on the other hand, after you know the area and the bin width, you can calculate the height. So the height actually that we call the density, mean how crowded in the bin. So here's the last question in lecture 8, right? So actually here we have another CSV file. They are represent the income for the actress. So you have 20, we only have 20, top 20 income actress. So they ask you about, if we want to make a histogram, okay, what is the height of each bar in this histogram? So remember last week we only asked you, what is the vertical unit? So that means the unit for the height. So here we told you we make the income is the column we want to observe. So we create a histogram. So we have our bin. So remember here your x-axis, actually the numerical attribute you want to analyze is the income in millions. So that's why in your height will be the percent per unit. So here, since our unit is millions, so your height is percent in million. Okay, so then they ask you, what is the height for each part we want to? So then if we want to know the height, yeah, we need to create the histogram chart. Okay, so here is the histogram chart we need to create. So that's why we told you here is the 2022 female actor, their income. So we only have 3 plus 17. We only have 20 top income actors. So that's we told you, right? Remember you have the bin we create. So actually they only have 1, 2, 3 interval. So using this 3 interval, 0 to 25 million, 25 to 30 million, 30 to 60 million. So we can create our histogram. So we use the income, the columns, and the bin is my bin. So the units, if you want to, that's just don't do the units yet. So let's show you here. Okay. Okay, so we just create the histogram like this. Okay, so I add one more parenthesis, so that's arrow. Okay, so that's why you can see here, that's the histogram we create. So then you can have the percent. You see that's a, the y-axis, that's a percent per unit. That's because we didn't specify the unit. But unit actually is the x-axis unit. So you can see here is a million. So if you really want to also display in the x-axis, so that's why earlier I comment out. So that's at the unit is millions. Okay, so then I'm missing. Okay, again, I mismatched the parentheses. Okay, so that's we get that. So we add the unit. So we back to see the question, what they ask us. Okay, so they want to ask us what is the height for each part. So of course, if you just see the graph here, yeah, they can easily to read. So the height for first one is 2%, then the second one is 4%, and then 1%. Okay, but sometimes like we say, are we really sure that's the data we read? So if we really want to get percent, okay, so we need to know for that column income millions. So it's better actually we just create the bin data. Okay, so remember we told you have your income table. So then you can add the bin. So the bin is my bin. So here you can either using the column name, the column index is 1, or here that's the column name. Okay, so either way is fine. Okay, so then we see our bin data. So again, you see here is the count. So that means each interval, what is the count? So if you want to know the percentage, right, we can add the percentage. The percentage actually is using the column. You see again using the 1, but that's mean here, this one in this bin data. So or you can just copy over the whole thing. But since in case I type wrong, it's better I prefer I use the index. Okay, so then because the total actress is 20, okay, so then we can get the percentage adding to our table. Okay, so that will be better to calculate on the percent on the height. So we know the first one actually is 0 to 25 since they have totally 50%. So here is 50%. So 50% divided by your width is 25. So right, the height for the first one is 2%. So then the second one, because 25 to 30, so that's 4. You see, sorry, the percent is 20. Okay, so 20, the base is 5. So 20 divided by 5, right? So the height is 4. So then the last one is 30, but also because the interval is also 30, so that's 1. Okay, so I just want to show you, you can either read from the table, but also we just calculate is better. Python all can do for you. Okay, let's spend some time here to see how you like this histogram. If we really try to interpret this histogram, you see here, that means for all the actors here between 0 to 25 million income, they are 2%. That's kind of mean for 0 to 10 million, we have 2%. For 10 to 20, actually that's 20% because 10. Okay, so they are all the same average. But really like that? We only have 20 actors, but if you try to see, actually the minimum income is 12.5. So honestly here is not exist. Okay, so now if not exist, how about we just change, we create another bin, and we start from the minimum value here. Okay, so then again, you still kind of similar interval. So we see after we do that, okay, so how the histogram change. But one thing is right, you see here they start from 12.5. Okay, so that's kind of more makes sense. And also you see if we do like that, actually the height changed. Okay, so that means from 12.5 to 30 million, they kind of distribute much better. Okay, also here, if we just don't choose any bin, we see what happened. Okay, so before we show you, right, actually Python will choose for you. Okay, so actually because that's this very small data, we only have 20 female. So this one actually kind of represent better. Okay, compared to the previous two histogram we showed. Okay, but one thing also we see, how about we make every 20? So here we just want to show the bin you choose maybe affect the histogram how to represent. And also historical usually used for the bigger data set. So this